Hey everyone, so this is going to be a video on these collision practice problems, and we are given three equations here. So the first one is the conservation of momentum. All right, so that says that our initial momentum is equal to our final momentum, and from there we understand collisions. So we have two different types of collisions. We have elastic and we have inelastic. So elastic collisions are when things do not combine or deform and no heat is generated. And inelastic collisions are when things do get deformed and there is a generation of heat. So let's go through number 1, number 2, number 3, and number 4, starting with Millie. So Millie is standing using frictionless roller skates while catching a 2.5 kilogram medicine ball, moving with a velocity of 14.5 meters per second. Millie has a mass of 45.8 kilograms. What is the final velocity of Millie and the medicine ball? So let's just say, let's just draw a picture. All right, so this is Millie, and he's on his roller skates, and there is a medicine ball flying towards him, and he's about to catch it. All right, so these two masses are going to combine. All right, and we want to know what the final velocity for Millie is. So let's identify M1, M2, and V1 and V2. And again, this is an inelastic, sorry about that, inelastic collision. All right, and our inelastic collision equation looks something like this: M1 V1 plus M2 V2, or the momentum 1 plus the momentum 2 of your second object, is equal to your masses combined times your final velocity for both. Okay, so let's designate M1 as Millie. And Millie is equal to 45.8 kilograms. And the velocity initial for Millie is 0 meters per second because Millie is at rest. Okay, he's just chilling on his roller skates. M2 is going to be the medicine ball. And the medicine ball has a mass of 2.5 kilograms and an initial velocity of 14.5 meters per second. So that is the velocity that the ball is coming towards Millie. All right, so let's plug in our stuff that we know. All right, so we have 45.8 times 0 plus 2.5 times 14.5 meters per second. And then our masses combine. So we have 45.8 plus 2.5 kilograms is equal to the, or multiplied by VF. All right, so we have our initial momentum total is equal to our final momentum total, but our masses combine at the final. All right, so let me move down my screen a little bit and we'll start solving this out. Okay. So 45.8 times 0 is 0 kilogram meters per second. And 2.5 times 14.5, we get 36.25 kilogram meters per second. And we're setting that equal to the masses combined times the final velocity. So this is 48.3 kilograms times VF. All right, so how do I get VF? Well, I need to divide both sides by 48.3 kilograms. I should say kilogram. Yeah, kilograms. Yep. All right, so we get, this cancels out on that side, so we get VF alone, which is exactly what we want. So we get VF is 36.25 divided by 48.3. It's 36.25 divided by 48.3, and we get 0.75 meters per second. Okay, so that is the answer. That is what Millie and the ball's final velocity is. All right, moving on to the next one. So a 0.5 kilogram toy train car is moving to the right with a velocity of 3 meters per second, and a 0.6 kilogram toy train car is moving to the left with a velocity of 4.5 meters per second. These two train cars collide head-on and stick together. What is the final velocity? So if they stick together, this is an inelastic collision. Okay, so our equation for that again is m1v1 plus m2v2 is equal to m1 plus m2 multiplied by vf. So let's draw a picture of what is going on here. So this is my cart 1 and cart 2. So these are about to collide head-on. All right, so there's going to be some type of collision here. And let's call this the 0.5 kilogram train because it is moving to the right. So that's going to be our positive side, it's going to be our negative side. So this is 0.5 kilograms and this is 0.6 kilograms. All right, so the velocity for the 0.5 kilogram one is v is equal to 3 meters per second. And for the other one, we have v is equal to negative 4.5 meters per second. That's because it's going to the left side. All right, so let's write down what we know. So M1, I'll just call it the first train here, 0.5 kilograms. V1 is equal to 3 meters per second. M2 is equal to 0.6 kilograms. And V2 initial is equal to negative 4.5 meters per second. Again, it's because it's going the opposite direction. All right, so let's write down what we know and solve it out by doing some math. Again, we're trying to solve for this final velocity. All right, so just to rewrite our equation, and now let's plug it in. So we have 0.5 times 3 plus 0.6 times negative 4.5 is equal to our masses combined times our velocity final for both. All right, so now it's time to break out those calculators and try this out. All right, so if you completed that math, this is what you should come out with. So combining to find our initial momentum total, the total momentum is going to be 0.8 kilogram meters per second. And remember, whatever we start out initially, we need to end with finally, which is why we can use this information to solve for our final velocity. All right, so again, we need to divide both sides by the total momentum. The total mass. That's going to cancel out here. So the final velocity is equal to 0.8 kilogram meters per second divided by 1.1 kilograms. So 0.8 divided by 1.1 is going to give us a final velocity of 0.73 meters per second. All right, moving on to the next one. So Jamal is at a state fair playing some of the games. At one booth, he throws a 0.5 kilogram ball forward with a velocity of 21 meters per second in order to hit a 0.2 kilogram bottle sitting on a shelf. And when he makes contact, the bottle goes flying forward at 30 meters per second. What is the final velocity of the ball? So if you've ever played these games before, you know that this is an elastic collision because the bottle and the ball do not come together at the end. So we're going to have M1 V1 plus M2 V2 is equal to M1 V1 final plus M2 V2 final. All right, so our initial momentum has to equal our final momentum. All right, so M1, we're going to say that it's the ball. So 0.5 kilograms, and that is the ball. And it's being flown forward with a velocity of 21 meters per second. So that is the initial velocity of the ball in order to hit a 0.2 kilogram bottle. So that's going to be our mass 2, and it's sitting on the shelf. So initially it's not moving. So that's going to be 0 meters per second. And when it makes contact with the bottle goes flying forward with 30 meters per second of velocity. So V2 final after the collision is 30 meters per second. And we want to know what's the final velocity for the ball. All right, so let's plug in our information. So we have 0.5 times 21 plus 0.2 times 0 is equal to 0.5, again because our masses do not change, times V1F plus 0.2 times 30. All right, so again, break out those calculators and solve for this. All right, and you should get the following information. So we are trying to solve for V1F, so we need to get this alone. So the first thing that I'm going to do is subtract by 6 kilogram meters per second from both sides. All right, and that is going to give me 10.5 minus 6. It's going to give me 4.5 kilogram meters per second here is equal to 0.5 times V1F. All right, so again, to get V1F alone, I'm going to divide by 0.5 on either side. All right, and that should give me V1F. So this cancels out here, and I take 4.5 and I divide it by 0.5. All right, so V1F is equal to 4.5 kilogram meters per second divided by 0.5, and so that is going to give me 9 meters per second. So that is the final velocity of the ball. All right, the next one. Janine rolls a 7 kilogram bowling ball down the alley for a league championship. One pin is still standing, and Janine hits it head on with a velocity of 9 meters per second. The 2 kilogram pin acquires a forward velocity of 14 meters per second, and we want to know the final velocity for the bowling ball. All right, so identifying what we have, this is an elastic collision because the bowling ball and the pin aren't going to collide and become one object. So we have M1V1 plus M2V2 is equal to M1V1 final plus M2V2 final. So our M1 is going to be the bowling ball, and the velocity 1 for the bowling ball is 9 meters per second. Okay, so M2 is equal to the pin, which is 2 kilograms, and originally this pin is at rest. All right, and we're trying to solve for the final velocity of the bowling ball, and the final velocity of the pin was 14 meters per second. All right, so let's plug it in. So 7 times 9 plus 2 times 0 is equal to 7 times V1F, which we don't know, we're trying to solve for, plus 2 times 14. All right, so do out this math. All right, so when you do out the math, you should get these answers right here. So again, I need to get V1F alone. So the first thing that I'm going to do is divide by 28 on both sides, which is going to give me 35 kilogram meters per second is equal to 7 kilograms times V1F. All right, so my velocity 1 final, or the final velocity for the bowling ball, is equal to 35 kilogram meters per second divided by 7 kilograms. So you should get 5 meters per second for your final answer of the bowling ball. All right, I hope this was helpful. If you have more questions, please let me know.